Alrighty, hey again, Honors Chemistry. So now I want to do another video with a calculation that we discussed towards the end of class in our notes that we might not be so familiar with, but it's easier than it looks. Alright, so let's see if we could try and figure out this question. And this is similar to question 2 on your worksheet. So question 2, it's similar. Okay? So, suppose while working out, you lost 2.15 kilograms of water due to sweating. If all of this water evaporated, how much energy did the water absorb from your body? Ew. Alright, so now let's try and figure out which equation am I using. I have Q equals MC delta T, and I use that for temperature changes, and I have Q equals MH, and I use that for phase changes. Which of these equations am I going to use? So suppose while working out you lost 2.15 kilograms of water due to sweating. So the process of sweating, so like water comes out and then like you get dry. If all of this water evaporated, how much energy did the water absorb from your body? Now, did this question give me any temperature in it? No, I mean you could assume that you're warm because you're sweating from working out, but there's no temperature in here, and it actually literally used the word evaporated. That is a phase change. So since this question deals with a phase change of a certain amount of water, I need to use Q equals M delta H. Or MH, sorry. Alright, so I need to use Q equals MH, where M is the mass of my stuff, and H is my evaporation or vaporization of water. And there's a number that I already have written here. The evaporation of water requires 2,260 joules per gram. All right, so looking in this problem, my M is going to be equal to 2.15 kilograms, and my H is going to be equal to 2,260 joules per gram. Well, my units for H are in joules per gram. So what do you think I'm going to have to do with this kilogram business? Now remember, there are 1,000 grams in 1 kilogram. Just like before, there are 1,000 joules in 1 kilojoule. So remember those conversions. How am I going to use those? Well, if there are 1,000 grams in 1 kilogram, if I have 2.15 grams, I'm most likely going to multiply by 1,000. So multiplying by 1,000 grams over 1 kilogram, and that's going to be equal to 2,150 grams. All right, so now I have 2,150 grams of water, and all of that water evaporated off of our body, and I need 2,260 joules for every gram of water that evaporated. So I'm going to plug this into my equation. Q is equal to, now my mass, it needs to be in grams, my mass of 2,150 grams multiplied by, oops, I don't like how messy this is, multiplied by my heat of vaporization, which is my phase change energy. That's 2,260 joules per gram. If I multiply this across, if I'm looking at my units, my grams will cancel out, and I'll be left with joules. If I do this math on my calculator, I'll do 2,150 multiplied by 2,260, and I get 4,859,000 joules. It's a lot of freaking joules. It's a lot of joules. 4,859,000 joules. Now, how many sig figs do I need? Assuming that I have a decimal point at the end of all of these, well, my mass had 3 sig figs, and my Q has 4, so my answer needs to have 3 sig figs. So either I gotta round this answer to 3 sig figs, so it'd be 4,860,000 joules, or in scientific notation, 4.86 times 10 to the 1, 2, 3, 4, 5, 6 times 10 to the 6th joule. That would be my answer with the correct number of significant figures. Make sure you're expressing your answers to the correct number of significant figures. If you forgot, count sig figs, which are non-zero integers, right? So 2.15 non-zero, 2, 1, that are all significant figures. Zeros after non-zeros are significant, except in the case if I don't have a decimal point. Zeros sandwiched in between non-zeros are significant. Zeros before non-zeros are not significant. So something like 0.02, that has 1 sig fig. 2.02, that has 3 sig figs. 2.00, that also has 3 sig figs. These are non-zeros after, these are zeros after a non-zero with a decimal point. The number 200 with no decimal point, that has 1 sig fig. So that's just like a quick cliff notes on how to do significant figures. Make sure you don't forget how to do that, because for the rest of this class and for all of your tests, you need to know how to put your answers in the correct number of significant figures. I have an older video on counting sig figs, so you may watch that from the very beginning, or let me know if you have any questions, comments, or concerns about significant figures. Alright, so I'm hoping the second video was helpful with calculations. Tomorrow, or the next time you do worksheet number 3, and when you start worksheet number 4, you'll be doing similar calculations. Either I use Q equals MC delta T, or I use Q equals MH. In the future, you may see both. When will I use both? If I heat up a substance, I change the phase, and then I heat it up some more. And that's seen in our heating curves. So I'm going to end this video on this note. If I have like a heating curve here, when I'm heating this up, I'm using Q equals MC delta T. When I have a phase change, which is that flat line, I'm using Q equals MH. And then when I heat it up again, I'm using Q equals MC delta T. We're going to mention this in our next class, but I could add all of these segments up to get the total energy that was added to something. So keep that in mind. Overall, make sure you know when to use Q equals MC delta T. That's if I have a temperature change. Know when to use Q equals MH. That's when I have a phase change. Hopefully this video was also helpful. Make sure you use it to your advantage, because we're going to be having a quiz soon.